Hi, this is Lazyhead, and I wanted to make a demonstration video for the automatic mining ship I've made. The core of the ship's functionality is the tractor beam's ability to both hold an object without applying torque, and to report the orientation of an object with the tractor beam as a reference frame. This means that if the ship rotates around its center, an object like this cube that is held by a beam without any torque lets me know the current orientation of my ship. What is happening currently is the main tractor beam is temporarily enabling its torque and setting the cube to a pitch, yaw, and rotation of 0, which I use as a reference angle. My ship is a rectangular prism, and there is a row of rangefinders running down each face of it, as well as 2 rows on the front. These rangefinders are on hinges which flip 90 degrees. I use these to scan for asteroids, which you will see shortly. The scanning rangefinders have a full range of 1000 meters, and as the 4 rows of rangefinders on the outside of my ship slowly flip to scan what is ultimately a disc-shaped volume, a large amount of space is scanned. The 2 rows on the front of my ship trace out 2 intersecting half-discs which intersect to form a sort of plus-shaped pattern. This is a basic configuration but still requires the ship's design to be very economical with any attachments on the outside of the ship. Once the cube has been reset to its reference angle, the scan begins, the rangefinders turn on, and the hinges begin moving in small increments. The hinges cannot open very fast, because at farther distances, rapidly moving rangefinder beams would likely pass over asteroids before YOLOL would have a chance to interpret the rangefinder data. The scan takes a while, but for the volume it traces out, it is thorough and usually will not miss an asteroid. Lowering the step value for the opening hinges allows for more accurate scans, yet also can increase the length of the scan by an order of magnitude or more, so the trade-off is up to the user. A total of 52 rangefinders participate in the scan. Rangefinders could be placed in a more dense configuration if individual config code was provided for any alternate configurations, but because the ship is more or less a proof of concept design, I went with single rows of rangefinders which are overall rather simple. When a rangefinder reports a distance of less than 1000, i.e. when it detects an asteroid, the scan stops for a moment. At this point, the detecting rangefinder's position along the ship, detected distance, and the current angle of the hinges are being stored. These 3 variables allow me to use YOLOL's built-in trigonometry functions to determine the precise location of the asteroid in relation to my ship. After these values are stored, the scan continues, and if the scan detects a closer asteroid, the stored data from the previous farther asteroid is overwritten with that of the closer asteroid. The scan will continue until the hinges have flipped 180 degrees, at which point the ship will do the necessary math to orient itself to point at the detected asteroid. I use a spherical coordinate system for this because it is what I am used to seeing in an astronomy context. The ship yaws a certain angle, then pitches, and roll is not involved. This method is sufficient for any location of a particular detected asteroid, although my code is flawed for pitches and yaws that are close to 0. These usually occur when the hinge angles are close to 0, 90, or 180 degrees. As the scan ends, the main tractor beam sets its torque to 0, and the cube in the center is now essentially free-floating. After calculating the yaw and pitch necessary to orient towards the asteroid, the ship begins firing its yaw thrusters in small increasing increments beginning from 0. This is to find the smallest thrust possible that will still cause the ship to yaw. When trying to have the ship's orientation be within a certain small amount of the target, knowing the minimum thrust necessary is very useful and helps with small precise movements. The benefit of the floating cube and tractor beam setup can be seen here. When the ship begins to yaw, the cube remains stationary, and since the tractor beam moves with the ship yet does not move the cube, the angle it reports is the ship's angle in relation to the cube, which is at an orientation of 0 pitch, yaw, and roll. The orientation the tractor beam reports is constantly compared to the near orientation calculated previously, and when the ship has yawed to within about 0.05 degrees of the calculated angle, it lets itself drift and will move on to pitching if it is still within a satisfactory amount of the target yaw. Once it has yawed to the correct angle, the ship begins firing its pitch thrusters, and the procedure for pitch is essentially the same as the procedure for yaw. When the ship is done pitching, the ship will check if any of the 9 rangefinders on the front of the ship detect an object. If one of the rangefinders detects an object, the ship begins to move forward towards it. If none of the rangefinders detect an object for any number of reasons, the ship begins a new scan which may or may not detect the asteroid that the ship previously attempted to orient itself towards. If you are wondering why the tractor beam is constantly turning itself on and off, this is because the tractor beam only reports the orientation of a held object the instant it grabs it. To have a continuously reported angle, I need to keep restarting the tractor beam. That is why there are 2 tractor beams inside the ship. One of them never turns off and simply holds the cube in place so the cube doesn't drift out of range of the sampling tractor beam while it is turned off. When the ship is done pitching and an object is detected by the front rangefinders, the sampling tractor beam maintains its state because no further sampling is needed. The ship will now begin moving forward towards the asteroid. It does this very slowly because tractor beams do not hold onto objects very well while either the tractor beam or the object is moving. I have tried using cargo log beams and a cargo log frame to hold the cube in place so my ship can travel towards the asteroid quickly and not lose the cube, but beams didn't grab the cube and the cargo log frame caused my ship to creak, so I resigned to having a slow ship. Like the pitch and yaw thrusters, the box thrusters have a sort of calibration period. The thrusters fire until the force reported by the always-on tractor beam, in other words how hard it is pulling on the cube, exceeds a certain value. The thrusters cut off until the force reported by the tractor beam is below a certain value, at which point they cut on again. This is to ensure that the ship doesn't go so fast as to make the tractor beam lose its hold on the cube. After tweaking the maximum and minimum force values, I've managed to have the ship travel forwards at around 2.5 meters per second, which is not fast at all but is an improvement over the speeds of previous iterations, which were around 1 meter per second. I will speed this part of the video up. The ship takes about 2.5 minutes to reach the asteroid. When the front rangefinders with their now shortened distance detect an object, the box thrusters cut off and the mining code begins executing. As you can see, I have two mining lasers. Each of these lasers is grouped with a pair of rangefinders on its left and right. Like the scanning rangefinders, these two pairs of rangefinders are on hinges that increment their angle. Unlike the scanning rangefinders, however, these intersecting rangefinders have their hinges rooted on turntables, which will rotate slightly once the rangefinders are pointing straight forwards. With two pairs of rangefinders, this means that most of the space directly in front of the ship is traced out. The front of this setup was designed with the size of asteroids in mind, so any given asteroid besides the largest size should fit well within this scan's volume. The top pair of rangefinders controls the top mining laser, and the bottom pair controls the bottom laser. When either of the two rangefinders in a pair detect an object, the angle of the hinge, the angle of the turntable, and the distance reported by the rangefinder are sent back for trigonometry processing. This setup is a bit odd compared to that of the scanning rangefinders. I take the location of a detected rangefinder point in Cartesian coordinates, find the position of that point in relation to the mining laser that rangefinder controls, then convert it to spherical coordinates which are used to orient the mining laser towards the point the rangefinder has detected. This orientation system went through many iterations and it was a huge pain in the ass to set up, if I'm being honest. Like the main scan, the speed of the mining scan is inversely related to its accuracy. One could increase the value of every step and have the scan be much faster, but since the automated mining is the main purpose of the ship, I prefer to have it be accurate. Because the distances at play here are usually going to be less than 20 meters, one can have the scan go faster without losing a huge amount of accuracy. The way I have my mining lasers configured makes them only activate when they reach their target orientation. Theoretically, having them activate while seeking to their target orientation could allow for slightly more coverage of the asteroid as the laser sweeps across it, but that risks sawing off one of the protruding arms which hold the rangefinders. The end result of my system is that upwards of 90% of the asteroid is mined, which to me is not worth sacrificing the integrity of my ship to increase further. As you can see, the accuracy of the mining lasers is not very consistent. The top laser hit its target almost perfectly, but the bottom laser for this set of angles is off by 3 to 5 degrees or so. The trigonometry that determines the orientation of the mining lasers involves measuring the distance from a controlling rangefinder to the mining laser, which is difficult to measure exactly. The reported distance of rangefinders can also fluctuate slightly, which does not matter much over large distances but does have an impact at smaller distances like those involved with mining. The pairing of one mining laser with two rangefinders is not a required setup. One could have multiple mining lasers for a pair of rangefinders. One could have one mining laser with 4 rangefinders, 4 mining lasers with 1 rangefinder, or any combination thereof. Having one mining laser per 2 rangefinders was what I found easiest to work with, but getting creative with setups could potentially yield mining that is faster and more thorough. While the activity of the thrusters was based on values that were found during configuration periods, most of the values associated with my mining setup are constants that I entered myself. but the time spent turned on and the distance from a rangefinder to a laser are values that I enter and continuously tweaked with while debugging the ship. It would be possible to have the timing of a laser tied to the data reported by a rangefinder, and for the sake of lowering energy consumption would be worth looking into. As one of the pairs of rangefinders reaches the end of its scan pattern, which I adjust to not overlap with the pattern of the opposite pair very much, the finders in that pair shut off and return to a default position. The two pairs are independent, and are done as soon as they have finished with their designated area. Having the scan areas overlap leads to more thorough mining, but the duration of the mining scan is potentially doubled. The mining process takes a while as is, and I don't think doubling the time taken for an extra 5% of the asteroid mine is worth the time. As you can see, the mining algorithm leaves only a small amount of the asteroid remaining, and from the tests I have run this is almost always the case. It is nearly impossible to mine up 100% of the asteroid because of the aforementioned inaccuracies in the mining laser orientation script. After it is done mining, the ship resets the cube to its reference angle, spins around 180 degrees so that it doesn't scan the remnants of the asteroid it just mined, and then begins another scan. This means that as long as the ship is hosted, it will require no input from the pilot, and the mining is automatic from the point of activation. A button in the ship activates an exit function if pressed, which allows the user to put the ship in a state where the YOLO chips can be safely paused or restarted without causing any errors. As long as the ship is used in the way it is meant to be used, it can go for as long as the user wants it to. After the cube has reset again, the chips have all essentially reset, and the whole cycle begins again. I hope this explanation was educational in some way. If you want to discuss automation, other tech, or have any questions, leave a comment or DM me on Discord. My name in the Starbase Discord server is Lazyhead. Thank you for watching.